Hello everybody, this is a video for my 30S applied math students, and we're going to start by going over a couple of homework questions before we get into the new lesson. And we'll start actually with number 13 from page, I forgot what page that is, from page 173. So can everybody take a look at this question here? This is a very traditional obtuse triangle question. And let me just get my notebook into writing mode here and knock over my microphone while I'm at it. Oops, there we go. Okay, so as we get further into these word problems, I'm not going to give you this nice little diagram. Let's pretend like we couldn't see the diagram. Where would we get it from? Well, a building is observed from 2 points P and Q that are 100.5 meters apart. The angles of elevation at P and Q measure 40 and 32. So I'm looking at a building, but I'm looking at it from two different points. So there's the building. We're going to assume the building makes a right angle with the ground. And I have a point P here, say, and a point Q, let's say that's there, and they are 105.0 meters apart. If I'm at point P, I have to look up. Angle of elevation means it's the angle that goes up, right? So this angle going up here has to be 40 degrees. And the angle at Q, to see the same top of the building, is only 32 degrees. Now, I've probably exaggerated that a little bit, but you get the idea. What I've created is let's do this in purple. I've created this purple triangle right here from P to Q to the top of the building. I guess I should give this point at the top of the building a letter. B for building. There we go. So I have triangle BPQ. You can draw it away from the rest of the diagram if you want. That's not the only triangle in this picture, by the way, and let's put the numbers in it, right? It's 105 here, it's 32 here, and okay, I know that it's 40 degrees over here. This is a straight line, right? So this angle here in the actual triangle has to be 140 degrees. Get it? Because it's supplementary. Now, see, I'm getting a lot of people going, oh, that's what you do with this problem. Okay, so now from here, the goal eventually is to solve this height of the building. I'll call it H. But this height is not part of my purple triangle. It's part of this green triangle. And the green triangle is a right triangle. I can solve that with SOHCAHTOA. So my strategy is, what line belongs to both triangles? B to P. So my strategy is I'm going to use the purple triangle to solve for this length B to P, and then I'm going to use it in the green triangle to find how tall the building is. So let's see what we can do with this thing. Well, do I know an angle across from a side? Not yet I don't, but I will in a sec, because angle B is 180 minus 140 plus 32. So angle B is 180 minus 172. So angle B is a very tiny little 8-degree angle. Right? Which makes sense. The way I drew it is very skinny. Okay, so that's an 8-degree angle. So now I can use sine law on that. So I would like to find this line here, which I guess is actually little q in this picture. So q over sine of q equals b over sine of b, and side b is the 105 I was given. So I'm going to do two steps at once because I'm getting real good at this stuff now. We've done lots of it. I'm going to move sine q up, so that's the sine, and while I move that up, I'm also going to put the number in, sine 32, times the side that's b, 105, divided by the sine of angle b, which is the sine of the angle I just found, which is 8. Then I'm going to punch buttons. There it is. Let me get out of that. Okay, so the sine of 32, close my brackets, times 105, divide by the sine of 8 equals, and we've got 399.8 meters. Now that isn't what I'm looking for, right? That's this line here. I could put it in green, 399.8 meters. I can now use SOHCAHTOA to solve the green triangle because from that angle, the height I'm looking for is an opposite. This is a hypotenuse. Sine of 40 degrees is opposite over hypotenuse. So my height will be that number I just had. Whoops. That number I just had times the sine of 40. So that final answer is, move over you, my answer I just had times the sine of 40. And there it is. The building is 256.987. What do they want us to round to? Nearest tenth. So come back, answer, where are you? So to the nearest tenth, I'm rounding at the 9, but that makes it go up. So it's 257.0 meters. So there's number 13. Now, here's another one, number 15, where they don't give you a picture, they just give you a bunch of information. Let's draw stuff. Angle Q is obtuse, and R is equal to 12. So R is equal to 12. So I'm going to draw that R really kind of skinny. 12. There we go. There's our 12 degrees. There's R. Okay, if that's R, that means that side R, which is 10, has to be over here. But I honestly don't know. This is that situation we saw in our activity together. I mean, Q is 15, so let's make this side Q up here. So let's make it a little longer so we have more to play with. Now, I have no idea how long this bottom side is. If this 10, like, does that 10 go this way? Or does it go that way? Because remember, the bottom side could be as long as it wants. I have no idea how long it is. Which way does this triangle go? Well, they gave me another hint. They told me that angle Q is obtuse. So the angle across from this side can't be this angle. That would be an acute angle. So that tells me that I have to have this triangle here. So I'll just redraw it. It has to have R is 12, Q is 15, and this 10 can't go that way. No, 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 no. It's got to go back this way because I know angle Q. I don't know how big angle Q is, but I know it's more than 90. And there's no way it'd be more than 90 if I dropped the 10 this direction. So that's not my triangle. This is my triangle. And now I can find angle Q because I know R across from R. So sine of angle Q over Q is equal to the sine of angle R over R. And again, I don't mind doing two steps at once here. So the sine of angle Q is, move everything in, plug in numbers. The Q moves up, so that's Q. Sine of 12 degrees over 10. Oh, calculator. Oh, come on, you. There you are. Move over out of the way. 15 times the sine of 12, close brackets, divide by 10, equals 0.311. So that's the sine of angle Q. To get angle Q, I go inverse sine of my answer. I can't see the answer button. There we go. And I get 18.17. Oh, hang on, something's gone wrong. It was supposed to, oh, wait a minute, right. Oh, yeah. Okay, so hold on. Problem. Is this an acute angle? No. What's happened is, I had two choices on how to draw this triangle, right? I decided this wasn't the right choice. But you know who didn't decide that? My calculator. My calculator thinks I want this angle here. The calculator can't be told, no, we want the obtuse angle version of this triangle. So it gave me this angle. So what do I do with it? How do I use this angle to figure out that angle? Well, let me redraw it nicer. again, when I drew this triangle, I had the choice to put that 10 length side this way, which is the triangle I wanted. But I could have made it go this way. And since I have no idea knowing how long the bottom line is, it could have kept going all the way to there. Now, take a look at that blue triangle I made. I didn't draw it very good. But if it was just its own triangle, what kind of triangle is it? Begins with the letter I. How do you know that? Well, because both of these are 10s, right? That was the line that could have gone either way. It's the same line. So if my calculator figured out that this was, what was it, 18 degrees? Doesn't that mean this has to be 18 degrees? Because Bate theorem, remember that? Base angles of an isosceles triangle are the same. That means that this angle here, the one that I actually want, is how much? How would I figure it out? 180 minus 18 is correct. So this angle Q turned out to be 18 point something degrees. Let's go back to the number. What was it on the screen? 18.2, let's say. So it was 18.2 degrees, but we want, oh, what's the fancy word for when two angles add up to 180? What are they to each other? Begins with an S? We want the supplement of that, which is 180 minus 18.2, which is, let's see, 0.8. I'm not going to touch the calculator again. Let's see. That'd be let's see, if you take 18 away from 180, you get 162, so that'd be 161.8 degrees. Boy, that I did not draw that triangle skinny enough. 160, that'd be like that. Super skinny. Anyway, that's the answer I'm supposed to get. Somebody could check the back and make sure it's right, but I think we did it right. But yeah, see, the calculator doesn't know this fancy thing that we learned in our activity, that when you're given 3 givens, sometimes there's 2 possible triangles you could draw. Specifically, when is it that you get that situation? It doesn't happen when you're given, let's move over. It doesn't happen when you're given side, side, side. It doesn't happen when you're given side, angle, side. It doesn't happen when you're given angle, side, angle. It doesn't happen when you're given angle, angle, side. It happens when you're given angle, side, side. That's when we know we need 2 triangles. So let's go to lesson 4 now. Or lesson 4.3, I think. I think that's what I want. Yay. So that's where we're at. I don't know why that's still there. What's going on? My screen's making weird things happen. Okay, there we go. Make that bigger. The ambiguous case of the sine law. This sounds like a Agatha Christie novel. The ambiguous case of the sine law. It was Professor Plum in the boarding room with a candlestick. So what do we mean by the ambiguous case of the sine law? It is a sine law problem where the information given does not uniquely define a single triangle. And if you think back to our activity, we saw this in the activity a couple times, or once in the activity. We went through all 4 of the cases we're going to look like. If I tell you I have triangle ABC, and remember, ABC is going to be, in this case, it says any ABC, but we're going to talk about ABC not being a right triangle. So what's the word for that again? Oblique. So for an oblique triangle, I am going to say that I have a height h, right? Any triangle you draw me is going to have some sort of height I can drop down. Even if it's an obtuse triangle, right? The height happens to not be in the triangle, but it's still there. So in any triangle ABC, height can be defined as b times sine of A. Where does that come from? Well, remember, if I'm looking at a triangle like that and I'm talking about angle A, if I drop down a height, that height makes a little right triangle on the left. So sine of an angle is opposite over hypotenuse when you're in a right triangle. So that's why height is b times sine of A. And here's what we're going to learn with this. If I have angle A in this triangle and side A is bigger or the same as side B, I know I have an acute triangle and there is kind of one possible solution. Oops. I'm going to say one solution. If it turns out that this opposite side A is exactly equal to what the height would have been, then I have one solution. And this solution, I should maybe say, was, of course, acute. This one solution is a right triangle. In other words, the opposite side A that they give me is just long enough to make it to the bottom line C. We saw that in our activity when we had a 30-degree angle. Remember, I made you draw a 30-degree angle. I made you draw a side that was 8 centimeters long. Then I told you the opposite side had to be 4. And if you drew it properly, 4 was just long enough to make it to that bottom line. And the reason for that is because 8 times the sine of 30 is 4. So this little formula can tell me if I have this situation where I have even though they just gave me ABC and didn't tell me it was a right triangle, if A equals H, it is a right triangle. Now, what if the triangle angle A is acute? Oh, sorry. Am I going too fast? Okay, I'll give you a sec. I'll still start talking about the third one, though. If angle A is acute, but what if side A is shorter than side H? Well, again, there's a couple things that could happen. This was the first one I gave to you in that activity. It was we were kind of messing with it. We told you angle A was an acute angle. I think, again, we used 30. And then we gave you B was 8. And then I think we told you A was only 2. And then no matter how hard you tried, you couldn't make a triangle out of that information. Because if this A is shorter than the perpendicular right-angled height would have been, then it can't reach side C. No triangle possible. Finally, this is the ambiguous case. What if I give you angle A, I give you the side right next to it B, and I give you the opposite side A, but A is smaller than B, but it's bigger than that height would have been. So it's definitely long enough to reach, plus some left over, but I could have drawn the line this way or that way. I don't know which. So there are 2 possible triangles. And notice the one on the left here, this triangle, is obtuse, and the big one is acute. It'll always work that way. Oh, because, okay, again, there's 2 triangles possible. I'll highlight them. This pink triangle here, go away, notifications. Oh, my word. I don't know how to make this note go away. Close, there we go, settings, close, there we go. Oh, and now I'm not even in my program anymore, there we go. Okay, so this pink triangle here, which is obtuse, or this yellow triangle here, which is acute. That's the 2 triangles. Yep. Okay. You can watch the rest of this. I'll have it posted. Okay. All right, next. If angle A is an obtuse angle, again, there's two things that could happen. If the opposite side I give you is bigger than the side right next to it, then you have one obtuse solution. But once again, what if we're messing with you? If we give you a side, if we say angle A is obtuse, and then we give you side A is not as long as side B, well then how on earth is side A going to make it all the way down to side C? It's not. So just like the other one, you'd say no solution and no, oops, I didn't mean to do that, and no triangle is possible. So when I'm given one of these questions, I like to make myself a little sketch. So given the following information, determine whether or not there is one, two, or no triangles possible. This one is exactly the last one we just looked at. If angle A is 100, make a sketch of angle A being more than 90. Maybe I've exaggerated a little, but there we go. There's 100. There's angle A. The side right next to it is 10. B is 10. The side opposite A isn't as long as 10. How could it possibly reach the other side? No triangle possible. All right, let's try the next one. If angle A is 30, so I'm going to estimate a 30-degree angle in my head here, and B, the right next to its adjacent side, is 10, and A is 4. Is 4 a long enough line to make it to the bottom if B is 10? I honestly don't know. Some people are shaking their heads no, because they remember the activity. And they remember that you actually need to be half of 30 at least to make it to the bottom. Because sine of 30 is special. Sine of 30 is exactly a half. Well, let's pretend we didn't know that. Let's test. How long is this height? So the height is B times the sine of A, which is again just SOHCAHTOA rearranged. 10 times the sine of 30. And 10 times the sine of 30 is 5. 4 is less than 5. 4 is less than 5, so A is less than H. So once again, no triangle possible. In other words, the line they gave me only makes it part way down. It doesn't make it all the way to the bottom. Does the logic on that make sense to you? You have to check. In this case, we kind of knew it in our heads because we've seen it before. But that's only because sine of 30 is special. Sine of 30 is a half. Is the sine of 40 exactly a half? No. Sine of 40 is more than a half. Okay? And then etc. So 30 is the only one that you can kind of do mentally. So of course we're going to stick with 30 for the next couple of examples because that one we're familiar with. So what if I give you a sine of 30, again, a 30-degree angle, and this time B is 10 again, but this time A is 8. This is the situation where, again, there is two triangles. The 8 could go, let me make this a little shorter. The 8 could go this way, or, I'm going to try to redraw this exactly the same. Yeah, I already made it too steep. Or the 8 could go this way. In which case, this line's a little longer. So this is two possible solutions. How do you know that there's two? How do you know it's not just one? Because again, 8 could go in either direction. Right? It's more than 4, but it's less than 10. So it could go either way. All right, here's another 30-degree one. I'm going to try to keep drawing 30 degrees. And again, B is 10. But now A is 12. Could I take a line longer than 10 and go this way? No, it'd go past line C. And this is usually where somebody says, well, then make the angle at A bigger. You can't. It has to be 30 degrees. You can't move it. So the only way that side A could go is to go that way. So that's A is equal to 12. One possible solution. Does the reasoning of that make sense to you? The reason why, two possible solutions, because my unknown side A is bigger than the height I'd need for a right triangle, but it's smaller than the line right next to it. This one only has one solution because A is more than B. The opposite side's longer than the adjacent side. All right. Your turn. I'll give you a minute. I'll pause the video. Feel free to talk to the person next to you. Feel free to try to workshop this out. How many triangles is there in D? 1, 2, or none? And what kind of triangle are we looking at? So I'll give people a minute to play with this. I'll pause the video. And then we'll come back. Okay, we're back. And people are talking about this, and they're not sure what to think. So let's draw 62 degrees. 62 degrees is a fairly big angle, right? So there we go, 62 degrees. So there's angle A at 62 degrees. Side B, the one right next to it, is 3 meters. Okay, 2.8 is shorter than 3. Is it long enough to make a triangle? I kind of think so, but I want to make sure. What's the little formula that will tell me? Take the sine of 62 and times it by the adjacent side here, which would be a hypotenuse in a right triangle. And that would be the height this would be if it was a right triangle. That would be h. So punch that through in your calculator. What happens? Come here, calculator. You get sine. Okay, some people can punch buttons faster than me. I'm having a hard time turning the calculator on. There we go. Ugh. Sine 62, close brackets, times 3. 2.64. So what does that tell me? 2.64. That tells me that if this line here was exactly 2.64 and all those decimals, it would just make it to make a right triangle. But the line I'm given's longer than that. So that means that the 2.8 line could go this way, or it could go this way. And I don't know which way it goes. So there's two possible triangles. This one here in red, it is obtuse, and this one here in blue.
The holiday maze is in the gym, and the entrance is at the change room doors. There's also Halloween games out in the field.
Two possible triangles because A is bigger than H but smaller than B. Now, is every triangle we give you going to be labeled A, B, and C? And you can throw, no, we're going to give you other letters. So why don't we put this in words? How about the opposite? How about I misspell the word opposite completely? Ugh. The opposite side to my given acute angle is less than the adjacent side, but it's bigger than the line that would make a height. And that's how you know you have two solutions. So we'll pick it up there on Monday. You can try some of the questions if you want, but again, I told you if you want to take the weekend off and wait till we do more examples on Monday, you go right ahead. Okay? You wrote a big test the other day. If you want to have a holiday, Halloween weekend, take one. But if you want to try getting ahead on your homework, you can try the next assignment. Okay, I'll end the video there. That's all that people who missed the class missed today. Have a great weekend.